Hi, in this video, I'm going to discuss SLIMCC 8 conducted last year. Um, let's go to the questions. Let me share my whiteboard. Okay, hold on. Right. Okay, hope you can see my whiteboard, right? Sri Lankan Intermediate Mathematics Challenge Competition, SLIMCC. SLIMCC, right? 8. So this was conducted on April 21st, 2024 at the University of Colombo. Now the structure of this competition paper is that, what are my, okay, it is, my laptop is a little bit slower, right? It has 24 short answer questions to be answered in 90 minutes, and the first 8 are easy, and each of these questions get 5 points, right? Oh, I can't find my pin. Okay, hold on. Right. Okay. So each easy question gets 5 points for the correct answer, right? And then the next 8 are medium questions, 6 points each, and the next 8 are hard questions and 8 points each, right? Okay, and if you leave a question unanswered, then nothing happens and no points, right? And if the question is wrong, if an answer is wrong, then you get 0 points. That's it, right? But in SLMC, it's different, right? If you leave a question unanswered, then you get some points. And then if if an answer is wrong, you get 0 points, right? So that is actually to discourage wild guessing. But here actually there is no guessing, right? You need to solve problem and write the answer, right? So therefore, here in the scoring system, there is nothing for leaving a question unanswered, right? Okay, let's go to the questions. Okay, first question. What is the smallest number that can be made by using each digit of 202 and 4 of 2024 exactly once, and the operations addition and or multiplication any number of times, right? Now, here, a key observation is that there's a 0, and when you multiply the number by 0, you get 0, and 0 is the smallest. You can't get actually a negative number, from these digits by using addition or multiplication. So 0 is the smallest, and we can get 0 by adding 2 and 2 and 4. Okay, that 4 and multiplying this by 0, right? So this is 0. So the answer is 0, right? Okay, that was easy. Question number 2. What is the 2024 number in the sequence of numbers? 3 or 4, 4, 5, 5, 6, and so on, right? Now you can see that there's a pattern, right? So we need to count the 2024 number, the term actually in the sequence, right? Now it is easier, right? And this is just one way. I'm going to add 2 more terms here. 1 over 2, 2 over 3, Uh, um, and then this sequence starts 3/4 and 4/5, right? So now you can see that, right? The first term has numerator 1, second term has numerator 2, third term has numerator 3, right? So that means 2024 number, which is actually the 2026 term in this sequence, in this new sequence I constructed, right? So I need to get the 2026 term, and that would have numerator 2026, and the denominator is actually one more than the numerator, which is 2027, right? So this is the 2024 term in this sequence, right? Okay, question number 3. When 5 to the negative 5 is written as a terminating decimal, what is its digit sum? Now, you can write any number as a non-terminating decimal, right? So here actually, when you write 5 to the negative 5 as a terminating decimal, what is its digit sum? The usual digit sum actually is used for whole numbers, right? So the sum of the digits of the whole number, but you can also use it for other numbers, right? Okay, let's write 5 to the negative 5, which is 1/5 to the 5, right? And this is, okay, so what is 5 to the 5? So that is actually 5 to the 2 times 5 to the 2 times 5. So this is 25 times 25 times 5. I know 25 times 25, which is 625 times 20 times 5. And what is that? So that is actually 5 times 5 is 25. So it's a 2. 5 times 2 is 10, 12. There's a 1 here. Times 6 is 30, 31. Right? So what do you get by dividing 1 by this? Okay, my pen is acting. Okay, so 3,125. So you divide 1 by that. So 0, and then 0, 0, 0, right? You get a new pen. Now I'll continue with this. And then, I see. Yeah. And then we get another 0. And for that, actually, we have how many 3,125s? That's actually, we get 3, right? 3. So it's, 3 times 5 is 15. And then terms 2 is 6 plus 1 is 7. 3, 9, right? And what is it? When you subtract, you get 5, 9, 7, 2, minus 3, 6, 625, and then you get twice, right? So this is the 5 to the negative 5 as a terminating decimal, and its sum of its digits is what? So 3 plus 2 is 2025. And that's the answer, right? Okay. Next question. What is the percentage of square numbers among the whole numbers from 1 to 225, inclusive of 1 and 225, right? Now, I know that this is actually 15 square, right? That I know. So just to make sure that, let's multiply 15 by 15. So 15 times 10 is 150, and 15 times 5 is 75, and this is of course 225. So the from 1 to 15 square, how many square numbers are there? Well, there are 15, right? 1 square, 2 square, up to 15 square. So there are 15 square numbers, and altogether we had 225 whole numbers. And as a percentage, right, it is this percentage, and that is actually so 5. So goes how many times into 225? So 4, and then 45, 3. So that's 15. So let's get a different color. So it is what is that? Yeah, 100 or 15. So it is, I'm going to divide by 5, so it's 20 over 3. So it is actually 20 over 3, right? As a percentage, right? Okay. And then we have this question, number 5, if x plus 2y plus 3z, I'm not going to say 3z, right, is 120, and 5x plus 4y plus 3c is equal to 60. I'm also used to this because I studied in USA for some time. Then what is the average of x, y, and z? Right. So you might think that you need to find x, y, and z, and then add them up, and then divide by 3. But then, we are smarter than that, right? We know that there are only 2 equations. We can't find x, y, and z exactly, right? Because we need another equation, right? But what we want actually is not x, y, and z separately. We just want its sum, right? So if you look at these 2 equations with that in mind, you can see that if you add them up, right, you get 6x plus 6y plus 6c is equal to 180. And then what we want actually, this divided by 3. So that means this is equal to, this average, right, is equal to 180 over 6, right, times 3, which is 10, right? That's a nice number, right? The average of x, y, and z is 10, right? So let's go to the next question. So next question, number 6. So let's go back to my cool color, light blue. So here we have to find out the number of pairs x, y, where x and y are positive integer solutions of 20x plus 24y is equal to 24. Now this is a Diophantine equation. We know that, right? Diophantine equation. Now, if you don't know, you should Google up and find out. So Google is your friend, right? It's a great resource, so use it wisely, right? Right, how do we solve this? So first I'm going to divide the whole equation by 4, right? To simplify things, right? 5x plus 6y is equal to 4, not 4 actually. So 5 goes, no, 4 goes, uh, okay, into 20, 5 times, and then we get 506. Yeah, that's another, yeah, that what how Americans pronounce 0, 506, right? So then I'm going to solve this for x, right? So this is 506, like I'm going to say, minus 6y over 5. And then I'm going to take out 2 from the numerator. I get, so it is 253 minus 3y over 5, right? Now this is so 2 over, so 5 doesn't divide, 2 and 5 are relative prime, right? That means 5 has to divide 253 minus 3y, right, over 5, right? I'm not going to use modular arithmetic, right? I'm going to use it I'm going to do this without using modular arithmetic, right? So this is, I'm going to write this 253 as 250 over 5 plus 3 times 1 minus y over 5, right? And then you can see that from this we can say that, so let me get red color, the important color, right? So so this is a whole number, right? And 3 and 5 are relative primes, so that means 1 minus 5 should be divided by 5, right? So we can write it like 5 divides 1. Actually, no, divides actually, right? No, it's a vertical bar, right? Not slanted. 5 divides 1 minus y, right? Um, so let's get some room here to solve this, right? So maybe I should go back to my cool color because it's very cool and also it's clearly visible than red, right? So this means that 1 minus y is equal to 5 times n, where n is an integer, right? So this means that y is equal to 1 minus 5n, right? Now, y is actually has to be, so here, we have that, so this has to be x is positive, right? So that means a 253 minus 3y has to be greater than 0, right? So that means y should be less than 253 over 3. And this is 3 goes 8 times, it's 8 times into 25. So so that is 24 and the 1, and then 3 times 4. And then it is, yeah. So then y is less than or equal to 84, right? And of course, it is positive, right? So 1 minus 5n is bigger than 0 and less than or equal to 84. So we know how to solve this inequality. So add -1, so get -5n here, less than or equal to 83, right? And we divide by -5. So this, we get actually 105 bigger than the inequality is reverse, right? N greater than or equal to negative 83 over 5, which is negative. So 5 goes 1 times 8, 3, 33, 5 times 6 point 6, right? And this means, right, this means it's a little bit slow. Hold on. So this means negative 16 less than or equal to n less than or equal to 0, right? Because it is 105. See, n is less than 105, right? So n is an integer. So how many integer values are here? From 0 to negative 16, right? To the left of the number line. So there are 17 values. For each one of those values, there is a solution, right? So that means we have found the number solutions, right? And that is 17. So answer is 17, right? All right. So let's go to number 7. If any letter in the addition problem of best plus op plus luck is assigned either 1 or 2, how many different values can the sum take? All right. So let's see. So let's write it as a normal addition, right? Because then we can see best of luck. So this is an alphabetic. Actually, there's no line there, right? So best of luck, we just add them up. And then this question is about the sum. So each letter is assigned 1 or 2. So that means, so we can, any one of these letters, right? Either 1 or 2, right? Fine. And then how many different values can the sum take? Right? All right. So TFK. So if TFK is, each letter is 1 or 2, how many different values can T plus F plus K can take? So if all are 1, it is 3, and 1, 1, 2, it's 4, and it's 1, 2, 2, it is 5, and if it is all 2s, then it is 6. So there are 6 possibilities for this unit digit. So let me use a different color, right? And actually, we can clearly see. So here we have, for this unit digit, we have 4 choices. And then the same thing, right? SOC, same choice, 4 choices. ES, 2 letters. So 1, 1. So E plus U, right? How many choices? So 1, 1, 2, 1, 2, 3, 2, 2, 4. So 3 choices for this digit. And then same here, 3 choices. So it is 9 times 16, right? Which is, so this by the multiplication principle, you know that, right? If you do not know, you learn it. But for this problem, you can see that, yeah, if you multiply the number of choices, right, for each place value, then you get the number of different numbers, right? Different sums. So 9 times 6 is 54. There's a 5, and then 9 plus 5, 9 times 1, Yeah, it is 144. That is the answer, right? To this question. And number 8. Let's get a different color. Right. AB is a triangle, and P and Q are the midpoints of AB and AC. What is, yeah, so this notation is actually for the area. What is the ratio? The area of triangle PQC to area of triangle ABC, right? Now, since Q is a midpoint, PQ is a median, right? It's a median, right? And what is the area PQC? Triangle, right? You can see that, right? It is, what is that? Half of, right? Hold on. Half of the area of the triangle APC, right? Because AQ and QC are equal, right? So this half of the triangle APC and triangle APC. Now, PC is actually median of, so PQ is a median of the triangle APC. Median, says a median of the triangle APC. And PC is the median of ABC triangle, right? So ABC ABC triangle, right? So here, yeah, PQ is a median of ABC triangle, right? You can see my where my this thing is. Let me do something here. Wait, so let's see. Right now I can see it, right? So PQ is a median of the triangle ABC and PQ, and PC is the median of the triangle ABC. So this APC actually is half of the triangle in a triangle ABC, right? So that means, so this means that the area of PQC divided by area of ABC is actually 1/4, right? So what is this ratio? It is 1:4, right? The ratio is 1:4, right? Yeah, that's the answer, right? Okay, so we have just finished the first 8, right? So I'm going to wind this up, this video, right? In the next video, I'm going to discuss the next 8 of SLIMCC 8, the medium questions, okay? So, see you in that video, okay?